Given an unsorted array, we have to write a code to sort an array using bubble sort. So in this tutorial, I am going to explain a bubble sort and how we can implement them using iterative and recursive approach. So let's first understand what is bubble sort. So in bubble sort, what we do is we compare each pair of adjacent element and swap them if they are in a wrong order. Let me explain through example. So this is my unsorted array. So in this array, following elements are present: 6, 4, then 1, then 2, then 5. So in bubble sort, what we do is we first compare each pair of adjacent elements. So first we compare 6 and 4. So 4 is smaller than 6, so we move 4 here and 6 here. Then we compare next set of adjacent pair of elements. So we compare 6 and 1. So 1 is smaller than 6, so 1 is moved here and then 6 is here. Then we compare 6 with 2. Then 2 is smaller than 6, so we move 2 here and 6 here. So then we compare 6 with 5. So 5 is smaller, so 5 is moved in this position and 6 is moved at this position. So you can see after first iteration, my array is like this. So I have 4, then 1, then 2. So 4, I have 1, then 2, then 5, and then 6. So 6 is moved at last position. So in next iteration, when we compare elements, so we traverse an array from this point to this point. As 6 is already moved at last, so we don't need to touch this last element. So now let's start with next iteration. And now 4 is compare with 1. So 1 is smaller than 4, so 1 move here and 4 here. Then 4 is compare with 2. Then 2 is smaller than 4, so 2 moves here, 4 here. Then 4 is compare with 5, so 5 is greater, so we don't swap the position of element. Now after second iteration, my array look like 1, then 2, then 4, then 5, then 6. So 6 is already placed in correct position, then 5 is already correct put in correct position. Now in next iteration, I traverse an array from this position to this position and check if any element is in wrong order. Then I sub the position, so no element is uh, in wrong order from this to this point, so no need to swap. Then in next iteration, I run a loop and check element from this position to this, so they are already in correct order, so we get the sorted array. So let's see it iterative code, and then we see how we can solve this problem using recursion. So this is my code, and if you see the array element, so this is the array element 6, 4, 1, 2, and 5. So I am starting a loop from 0 to array length minus 1, from 6 till 5, and then I am using one more loop, and which is run from 0 to length minus 1 minus I. The reason being, at after every iteration, the larger element is moved at last. So I have already explained that, for example. So if my array is 6, 4, 1, 2, 5, and in bubble sort we compare adjacent elements. So the element which is the largest after first iteration, it moves at last position. So in next iteration, we need to ignore this position, as the largest element is already moved to last, then second largest, then third largest. So in this way, and if they are in wrong order, we swap its position. So this is the code of swapping an element. So, and we run a loop. So if array has 5 elements, then it run till it goes to 4 iteration. So, and after that we get the sorted array. So this is how this code works. And now let's see its recursive implementation. Let's think for a moment. This is the iterative code and how we can convert it into recursion. So if I show you the code, then this is the recursive code. So this is my terminating condition. If n is equal to 1, then return, else traverse an array till n minus 1. So remember, here what we do is we run a loop from 0 to n minus 1, and in next inner loop what we do is we subtract the value of I after each iteration. So here what we do here is, after we are calling this method and passing array, and after each iteration we are subtracting -1 from the array length, as the last element is put in last position after each iteration. So this is the recursive implementation of bubble sort. And let's run this code and see its output. So let's run first iterative implementation. So this is my main method. This is my unsorted array, and when I run iterative example, let's see its output. Here is my output, and let's run the recursive implementation. So if I run it, then see the output. So this is how we can solve how we can sort an unsorted array using bubble sort. So the time complexity of bubble sort is O(n) square. So I have demonstrated, I have explained bubble sort just for learning purpose. So in real scenarios or for large data set, we generally use merge sort or quick sort. And that's it for this video. For more such programming video, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video.